Yeah, are you able to see my screen?
Yes, sir.
So we'll move to the next aspect today. So we have got a stage-by-stage understanding of what requires to be done for data analysis. So we started with learning a bit of Excel, then doing calculus, some matrix. So we move to the next aspect of studying the probability essentials. So probability is very much needed, essential, important, and all to understand the concept. Like when we need to talk all about statistics and all, it's all about probability. We need to understand this thing and move forward. So whatever we have learned in terms of this calculus, formulas and all, same thing, some kind of things and all will come here in between. There might be challenges in understanding certain things immediately. So this PPT is also shared to you. So feel free to stop me in between if you have any questions. So we'll talk about experiment. What's an event? What's a sample space? What is probability? What are counting rules? Conditional probability, base rule, random variables, mean and variance. So a lot of things in one plate or one thali, I can say. So, but that's the best I could accommodate because there are a lot of things which has to come, but maybe not. So why learn probability? So let me move here up. So nothing in life is certain. In everything we do, we gauge the chances of successful outcomes from business to medicine to the weather. I think weather and all, I've already spoken a little bit about it in between our talks and all. So we gauge the chances of successful outcomes. So whether a business may be successful or not, whether the person may live or die, whether it will rain tomorrow or not. So all things and all are probability. So a probability provides a quantitative description of the chances or likelihoods associated with various outcomes. So it provides a bridge between descriptive and inferential statistics. So that is why we have to learn probability. Otherwise, a lot of problems will come. We will not understand why we should do, why we should construct hypothesis, what is the use of probability. All these questions come again, again, again. It will hit you like missiles. So we don't know what to do. So it is better to be perfect than get into a lot of problems later or whatever. So this is how it works. So from population means the large population like India. If we take sample, that's a probabilistic way of understanding. When we have a sample, we talk about it using statistics to talk about population. So this is how the probabilistic mumbo jumbo happens. So that's what we need to know. So population means, like for example, population of India. So you need to know, you can't have, you can all study, because whatever we study through population, I mean, it's like a census completely of Indian population. If you want to study the buying patterns of Indians and all, you need not study all each and every 140 crore people here. You can have not even say about 1,000 or 2,000 samples or something like that of this thing should give us the buying patterns. But the choice of samples should be very clear. So why, how, and all. So why we need to take a sample and all, we learn going forward. But this is how the cycle works. So through a probabilistic assumption, we come to a sample. Using a sample, we talk about the population. That's about statistics. So that's how the cycle works. Let me distinguish between probabilistic and statistical reasoning. Suppose I know exactly the proportions of car makes in Bengaluru. Then I can find the probability that the first car I see in the street is a Maruti Suzuki or whatever it is. So this is probabilistic reasoning, as I know the population and predict the sample. So the figure which I showed you in the last slide is exactly what I'm trying to describe here. Now suppose that I do not know the proportion of car makes in Bengaluru, but would like to estimate them. I observe a random sample of cars in the street, and then I have an estimate of the proportions of the population. That is statistical reasoning. So were you able to understand this thing? Is it confused? Let me know what you understood. Yes, anybody? Was I able to really convey what? No, I did not hear anything. Can you
Yeah. The probability actually is we have to calculate na 7 less than 6, 5 like that. We have to calculate the probability. So there is a possibility that you have to make how many permutation and combination the probability one.
Yes. So okay, that's one this thing. Anybody else would like to say? Yes. What? See, something should strike your mind actually. Let's have a conversation, because if I go on speaking like out of practice and out of my own understanding and all, I'll speak. Because something has to really sit in your minds. That's very much important. Anybody? I have given an example of some car. So you can think of something else and tell me like how do you understand that thing? Say whether
The ticket actually the mobile number, they are using the permutation combination to assign the mobile number. Because the number is limited 10, but there is a permutation combination, so it will help.
yes. Yeah, that's one more reasoning. Yes. Okay. Like this, lot of things which we should see. Probabilistic is something like it is basically theory only. So like how you assume, how we speak about it and all. Because many things like all are postulated. So if I say postulated, say probably, those kind of things come here. So somebody postulates a problem. So we have something to prove something, then statistics is used. So probably a probability is something like you have to assume things and try to do it. Because without assumptions, we cannot start. Say for example, today if you are seeing news and all, we are rather bombarded too much. So, so how Indian Prime Minister did some reasoning, like for example, probably he assumed so many, he had to talk some kind of things, then try to evacuate Indians from Ukraine. So these are some kind of probabilistic or some kind of strategies being played across. So theory on ground, we don't know how it works and all. So like when the people go there only, then they have to see who, why, and what and all. So the reasoning is that probabilistic kind of a thing. You have to assume things like, of course, there will be many. Modi is not the person. There are a lot of tons of people like who would have really contributed that to like what are the chances, like how we can bring back and all. What is the air way which we have to choose? What are the countries we need to talk? So all these kind of strategies are trying to like some kind of probabilistic reasoning we have to. Business also we have to assume so many things and try to put it. So that is where things come up, because we have to think a lot. Then only we get an answer to our problem. So in the coming lectures, we use numerical measures to describe data sets which are used. When I start talking about statistics, the data which I show on this screen is a sample of some population. So in course, it is some population, I don't know. So that's how we start using. Page down not working. So we measure how often using relative frequency f by n. As n gets larger, sample and how often is equal to relative frequency. So how often we have to measure? So n is samples. So f is some kind of assumptions which we need to make the function or something like that. So whatever the answer which we get is a relative frequency. So that is how we tend to understand about the sample and how often and all. Because this how often and all is theoretically correct, but in practice, how we use it is something which we need to know. The sample to population relative frequency is the probability. An experiment is the process by which an observation or measurement is obtained. So these are terminologies which you need to understand. Don't get confused at all. Things are highlighted here. When I say this thing is very much important. An event is an outcome of an experiment, usually denoted by a capital letter. The basic element to which probability is applied, that's an event. When an experiment is performed, a particular event either happens or it doesn't happen. So tomorrow it may rain or it may not rain. So that's an event. So when you perform this thing, it may happen or it may not. So that is something which we have to. So these are all assumptions. When Indian flights went to praying for getting Indian students stranded there, it's only a chance. I don't know. Well, coming back, it might have been bombed or something. But all things have to be taken into consideration. So that's an experiment which was performed, I can say. And the event was like sending a plane, getting here and all is some kind of a thing which you can think of. Experiment means I record an age. So a person is 30 years old, person is older than 65. So one more experiment. When I toss a die, observe an odd number, observe a number greater than 2. So everything is quite true here. So this is an experiment. So whatever A and B is an event in that. So basic some more things. Two events are mutually exclusive if when one event occurs, the other cannot, and vice versa. So experiment, toss a die, observe a odd number, observe a number greater than 2, observe a 6, observe a 3. So I have got 4 events happening here in this experiment. So any event is mutually exclusive. When one event occurs, the other cannot. When I toss a die, a single die I am talking about, I can observe an odd number. An odd number is 1, 3 or 5. If 6 is the largest number on a die. So now I can observe a number greater than 2 also. And I can observe a 6 and observe a 3. So these are some kind of a mutually exclusive events.
Professor, B and C can happen together, right?
Sorry?
B and C, observing a number greater than 2 and observing a 6, both would happen together. Like if we get a 6 on dice, the number would be greater than 2 and we are observing a 6.
Yeah,
so
definitely.
both the events are happening.
Both can happen, but they are mutually exclusive, like to the context of what you are talking about. That's all. It's all hypotheticated way of understanding. So not mutually exclusive, these two things. These are mutually exclusive. That's why I'm telling it's a bit confusing. So why this theoretically understanding, putting it, see, you may not use it in a practice. You have a set of numbers, you analyze it, that's fine. But to articulate in front of a client and all, you may not use this kind of a thing. But when you have to, you are in such a situation, it has to be explained in a quite cumbersome manner, and the client is not able to understand certain things. And you have to bring these concepts together to really say that how you have sampled the data, what is the basis of your assumptions and all, and how you analyze the data and all these things will be a part of that. Now I will show you like a distribution, like how exactly start putting the numbers to it. So each one single die is something like one number. So for example, like performance of students, for example. So your performance, my performance in some examination and all, each scalar quantity is an event. Both are mutually exclusive. So that's how we have to see. Of course, there are a lot of challenges in which people may agree, may not agree and all. But this is how things can happen. So I think your thing comes up something like this. B and C is a question mark. B and D is also a question mark. Anything can happen here. We don't know, like, but exactly the observation. That's why we say that when it is reported, we take that particular thing of data, then only things happen. This is only a construct to the problem. An event that cannot be decomposed is called a simple event. Denoted by E with a subscript, each simple event will be assigned a probability measure, how often it occurs. The set of all simple events of an experiment is called the sample space. So all our mathematics was taught using Euclidean space. If you remember. I think it was may have been mentioned now, or that may not have sat in our minds at all. Even today, whatever maths we are learning, part of the curriculum, anything it might be, is some space that is known as the Euclidean space. So when I say some space and so it is like today we are living in Earth, so it is part of one solar system. So they say that there might be enough solar systems in our galaxy. So that's how we have to conceptualize things. So theory. So this has to be said. Why? Because like simply like we get a data, we perform, and that's fine. Some things are today even more black box. They say that just throw the data to something, it will give an no. Please don't go by that logic and all. You have to understand why it was taken, how it has to be done. So of course, after experiencing this for about say 5 to 8 years, then you can say that, oh, I know that it's all trivial. To come to an understanding of the trivialness is something we have to be very careful. One example. So I told you how we can take it. When I toss a die, simple events. So in a die, it is only 6 which I have it. So first one is even. When I get a 2, it is E2. So up to E6. If I put everything in using a symbol S, all these events will be form a set kind of a thing. So set theory we are aware of. Set theory and probability are somewhat related together. So this is a sample space. So what I told, each is a separate event denoted by E. So if I get one, so it's 1, 2, 3, 4, 5, 6, whatever it is, we can name it with a subscript. If I put everything into a space, this forms a set of data to me. So do you agree to it? A sample space forms a set of data to me. Would you agree?
Yes, yes.
So we have something, so a data emerged through something. Like, for example, you do some kind of survey or something, you are collecting data. So you approach 100 people, collect data, put it in a column or set of columns. So that becomes a set of data to me. Today, now on this thing, I toss a single die. So in all the 6 things, you may not get 1, 2, 3, 4, 5, 6. You may get 2, 3 times also. That's all. But each is a separate. All are mutually exclusive. I'm telling. I might get 2 times, 3 2 times. So 4 is done. So 2 more thing is like I may get 1 and a 6 also probably. I don't know. But if we define something, chances that in a die, if I throw a die and get what exactly it comes, so I have got only separate things are 1, 2, 3, 4, 5, 6, and I denote by E1, E2, E3. So that's how it is. So this is in some space. So this, while we graph some things, for example, we did a little bit of graphing. You remember that on a space how it was there. So when you see this thing, like if you put a vertical line, a horizontal line, and where all things fall. So in a space, for our conceptual understanding of a visualization, we require this kind of where it is placed. So, for example, E6 is some number, for example. So what is the weight in the space? So when you plot it in a XY plot or something, like it has a position there. So that's a sample space. The graphing is that sample space. So they say that a picture is worth 1,000 words. So if I got 1,000 records, if I translate it to one picture, oh, people will say fantastic, they can understand it. That's how your understanding about data analysis should be. An event is a collection of one or more simple events. That's fine. The die toss. So A is like an odd number, a number greater than 2. Whatever it is, it may come there. As I told you, if I say only an odd number, I can put a boundary against it. So this is some kind of a Venn diagram. Remember your set theory. You used to group something, and there was some intersection, something like that have been there. So whatever is there are all odd numbers, probably that has been grouped one way. See, things are overlapping here. So what happens is, like for example, E3, E5 in a graphical kind of a remove the understanding of odd number or even numbers. No. You think, for example, this is a part of that itself. So these things meet together. So for example, certain numbers, the colors or something, colors of cars. So here also, it is not the distinguishing thing between odd and even. So chances are there, have a set of events or something like that. So A is only an odd number. That's where the one boundary condition comes. E3, E4, E5, E6 is a number greater than 2. That forms a separate space. The commonality in this thing is E3 and E5. So that's how you have to conceptually understand it. Now, from an event, we learned experiment, event. So how do we name it, put it in a sample space and all. Then suddenly I talked what's about, I gave a reasoning about probability. Then we talk about exactly what's the probability of an event. So probability of an event, A, denoted by A, measures how often A will occur. We'll write that as P of A. So usually in textbooks or for presentations and all, when I say P of A, we highlight things. We need not highlight and all, but that's how we have to understand it. Suppose that an experiment is performed n times, the relative frequency for an event A is number of time A occurs. That's what I told in a couple of slides before. That is F. N is the number of times. Only A occurs is F. The total number of times barring n, including a also, that's the n. So if we let n get infinitely large, so I think in probably in our +2 or something like that, or in our college days, we studied something like limit and all. I think the book which I shared you has some ideation about this thing also. So probability of limit n tending to infinity is f by n. So that's how we say about this formula. Limit and all will, but whatever mathematics we learned, actually is in our what I call our high school days, in our college and all. So these are some things which are applying to the concept of data analysis. That's how these things come. So probability of A must be between 0 and 1. Then if event A can never occur, P of A is 0. If event A always occurs when the experiment is performed, then P of A is 1. So the value of probability should always be between 0 and 1. The calculation something greater than 1 and less than 0 and all, no, you are wrong. So it should be always, it's a full bound, it's not put in a round bracket, it's a square bracket. So always the value of the probability should lie between 0 and 1. Please take this thing. You should never go wrong on this thing. Sum of probabilities for all simple events is equal to, definitely. So when I say about that probability of events, E1, E2 or something, each one will have some kind of probability associated. So chances of 2 falling will have some probability, for example. If you add everything also, the total should always come to 1. It should lie between 0 and 1. The total of all probabilities of an experiment or some event, the set of events happening for a particular problem should always equal to 1. Please keep that in mind. That's what it. Probability of an event is found by adding the probabilities of all simple events contained. It should always go to 1. If you get beyond 1, no, it won't come usually, but it should not cross 1. Then if you get 1.0012 or something like that, okay, accept. Then after 3 zeros, decimal places, that's fine. It's all rounded to 1. But if you get something like 1.23 and no, not acceptable. So it has to be touching 1 only. So how do you find probabilities? Probabilities can be found using estimates from empirical study, A to Z, whatever we do, A of anthropology, Z of zoology, all will have empirical studies. All will has to do with data analysis. We find probabilities for this. Common sense estimates based on equally likely events. We do commonly based on experience. Say, for example, as I told you, so when does rainfall start in India? So it crosses the Kerala coast somewhere in the first week of June or second week of June or something. Usually, if we take the data of May complete and all, if it was rain or something like that, so probably we may get a chance saying that, yeah, it may rain in June, but it may not also. So usually what happens is like you get the pre-monsoon rains also sometimes. So based on that kind of estimate, it's a common sense estimate. So it's an experiential understanding. So like common people like us also can do it, or people in the field, people in it will be completely common. For example, you work in a domain, whatever the estimates, it's your common. You people also have 5 to 10 years of experience in. So you also put some probability numbers to it, then it's a common sense estimate. Of course, all these examples and all to teach probability will be using throwing a die, tossing a coin, playing cards and all, because all probability was invented in a place known as Monte Carlo. So Monte Carlo is a country / state or something like that. You can talk it. It's a very small entity in Europe where you have all this gambling dens. That's where probability originates. A lot of mathematicians who saw this kind of a thing, put a structure of mathematical assumptions and all towards that kind of a thing, then things became more sensible to people. So if I talk something like gambling and all, so probability has its origin in gambling only. So sorry for that thing. Don't tell that Amarnath is teaching gambling, but probability will be understood to mainly three things. Like one is toss of a coin, one is a throwing a dice, and one is a card game. So I think all are cricket aficionados class. Probably if somebody Virat Kohli tosses a coin, so that's also a probability whether he will win a toss, whether he will not win a toss. I think before a T20 match or something like that, both captains will toss. So if A team wins a toss, so what are his chances of winning the game? So if B wins, what is the chances? So what are the factors? Whether who are the all-rounders, who's the bowler, who's the batsman, who has scored what and all. So each one will have a record for him. So do you agree? Can you understand this thing what I'm talking? Especially through cricket.
Yes, Professor. Yeah.
So that's how probability works. I think today lot of cricket statistics are shown or something. So this is data collected, but we don't know like T20. I think it's about to start in some summer, right? T20s and all. So like everybody will sit together, watch a game of cricket, like the IPL, I think. So each one of you will have a what we call leaning towards a particular team or player or whatever it is. Probably if you have data and all, probably you can say like make an assumption. Probably if he bats, what would he score? Or if he wins, somebody wins a toss. So which is the venue? Whether it will rain there, how much heat was there. So what are the lighting conditions? So these are all some things. These are all variables or factors which affected you. So I don't know, like luck also. Virat Kohli's luck usually runs out in certain points of time. So it is something like I may model a problem based on some assumption. So these are all common sense things, like our experience is matter. That's how.
But Professor, that the Bangalore every IPL second half it's raining. Everybody knows. Still the IPL they are playing.
Yes.
Second half every day it's running. It's not 1 year. It's from 2013 to till now COVID is gone, but every time it's raining.
Yes, absolutely right. Yeah, so that's the way. So Survi's common sense thing is like she will put a column of data like the second half it will rain. So she will put a dummy column there. You'll have other statistics means like the data available. Her thing is like she'll put one more factor whether somebody wins the toss. So this factor also should be considered for modeling the problem. So that is a probabilistic estimate which Survi puts for her modeling. So that is how we have to understand probability. That's how it is. So this is like experiential learning. Immediately, nobody even, I didn't know. For example, when I graduated also, when I did my master's also, up to master's, like if it was a thing from a textbook or something like that, I could understand and do it. Then when I started really doing the live work and also that started to have an understanding of why linkages between probability and statistics happen. Even though I'm a statistician. My understanding developed after my experience hands-on. When I started dirtying my hands in survey studies also, in the secondary data studies also, then only I started getting this kind of experience. Now I have also faltered. So I don't say you will falter or something like that. Chances are that you may not really solve a problem the way it has to be solved. So it may take some experience, but this understanding helps. Very much important. So when I toss a coin, probability of head is 1/2. That's what the cricket example. That's why it is shown here. So wherever probability books on the internet, everywhere somebody might have given some other thing, but for basic understanding, it has to be a toss of a coin, a card game, or throwing a dice. All are gambling. Suppose that 10% of the US population has a red hair, then for a person selected at random, probability of red hair is 0.10. So that is how we tend to understand it. So that is 10 by 100. So 0.10 is the probability that when a person selected at random is 0.10. That's a probabilistic number. Suppose that 10% of the US population, and this is how we try to articulate things. The probability of a event A is equal to sum of probabilities of the simple events contained in A, that we saw in that example. If simple events in the experiment are equally likely, then you can calculate something like P of A equals N subscript capital A divided by N, where that is number of simple events in divided by total number of simple events. So the formula starts. Today you will not calculate things and all. Excel can solve for you. An example, toss a fair coin twice. What is the probability of observing at least one head? So fair coin means like I have one coin with me. So one is the head, other is the tail in a coin. So what are the things? So if I use the second coin, fair coin, if I have to say, so I can get a chance that it can be H and T, H and T. So if I put a event to this thing, so what are the chances of two things? So two events has happened there. So that is HH, one is HT. So just I am linking that thing, whatever is there in that diagram there. First thing is T by H, other is T by T. So if I put some probabilistic numbers to this thing, right? So one is 1/4, other is 1/4, 1/4, 1/4. Probability at least one head. So what are the things? I have to discount the fourth one here. So that will be P of E1, P of E2, and P of E3. So 1/4, 1/4, 1/4. So probability of at least getting one head is 3/4. So tossing a fair coin twice, what is the probability of observing at least one head? That's what my problem. That's how we have to solve problem. So we will not get this kind of a thing and all, but how probabilistically you have to put an things to your estimates is what I'm trying to give you an example. So immediately it may not sit in one's mind and all. So understanding fair coin. So what are the chances of if what you call if Chennai Super King wins a toss against our what you call Hyderabad, this thing or whatever it is. So like You have to see this kind of chance. So I don't know, pair coin to me is like the way which I put it. I also take a coin thinking that I am poly or something like that. I start tossing and so I start putting these things here, trying to map and all, and I put a probabilistic number to it and I get an answer. That's what I will try to do. One more example. A bowl contains 3 M&M's candies. I don't know, M&M's are something to do from an US this thing. I think probably there's all some brand, I think. So these are some candies. So one red, one blue, and one green. So it has only in a bowl, it has got 3 color candies. A child is asked to select 2 M&M's at random. So what is the probability that at least one is red? So it's in a bowl, M. So that's a candy. So a child will be asked to pick something like that. So a child selects 2 M&M's at random. So he or she picks it up. First one will be a blue one and a green one. Then again it will be put back to bowl. Second one it will be red and green again. Again it will be put back to the bowl. So it will be blue and red in the third try. So if I put it as an event now, so from the bowl, so red and blue, so that will be R and B, R and G, B and R, B and G and B, G and R. Attach whatever it is. So it is 1/6. Why? Because 6. So 6 is the number of events which has happened like. So each one is a one probability I have to put 1 divided by 6. So for all things, the same things come here. So probability at least one red. So what are the scenarios which I have to pick up? So that will be the first one. So one will be the second one, the third one, and the fourth one. So that will be 4/6 is equal to 2/6. So we learn calculus, solved it in Excel and all. Or why we learn calculus, probability, algebra, matrices and all. So this is how in practice, this is an understanding which we have to build it here. That is important. So this was a second example. So the sample space of throwing a pair of dice. See how complex it is. So people gamble. So there are compulsive, impulsive gamblers also. So they will know like probably it's a chance, it's a luck at the end of it. But what are the chances he or she win or something? This is an understanding we try to do it. These are all the combinations when we sample space of throwing a pair of dice. So pair of dice, 2 dice which will have numbering from 1 to 6 and all. So the first will be, so both will be different colors, 2 dice, 2 separate, 1. Maybe let me get it, I don't know why it's. So this is all the probably the things which you will see like somebody talks. So these are all the complete combinations which we get it. So dice which adds to 3 simple events, 1 and 2, 2 and 1. So that is 2/36. Dice add to 6, 5/36. Red die which shows 1, 6/36. Green die which shows 1, 6/36. Why 36? Because you can get the maximum number is 6 only. So 6 into 6, 6 is 36. So this is how you put in what are the chance, how events are understood, what's the probability we put to this thing. What?
Sir, I didn't understand how did we get 36? If you can explain once more.
Yeah, because a die has from 1 to 6, right? So the maximum which it is 6 into 6. 6 6 are 36, right? So that will be your denominator.
But two pairs of die. Oh, okay. I got it, sir.
2 pairs. 2 separate pairs.
Correct. Got it now, sir.
One die color is red, one die color is green. So you see the last thing here when I am homering my mouse. So this is a chance. I don't know. If I toss it, I may not get this kind of. So that's a probabilistic. It's an assumption. That's
Got it.
yeah. So where dice add to 3, 1, 2, and 2, 1. So where is that 1, 2, and 2, 1? Let's see. This is 1, 2 here. That's one thing. Where is 2 and 1? Here. 2 and 1. So this is the way which we try to do it. So I think if you have played a roulette wheel or something like that, I don't know. India doesn't have. Probably if you have gone to Goa or something like that, if you have gone to a casino, it should be on the sea or something like that. So Indian laws doesn't allow officially to gamble on land. You have to be on the sea, gamble the roulette wheel. Like, what are the chances? Like, put some money, pull that this thing, you get something like that. So chances we don't know. Your luck also. So what is programmed behind that machine is probability. So what is called that the empirical way of coding the probability. So what is actually coded is the statistics. So when I talk about statistics, so what is the thing? It's basically numerical analysis, some kind of functional calculation which we have learned. A complex algorithm could have been coded here. You like that 3 bananas, something like that. So you put some money to this thing and all. Say abracadabra, you remember all gods or something, pray, all money should come and all, you go pull that this thing. So you may win or you may lose also. It's a probability. So that's how things. We'll talk about counting rules. Sample space of throwing 3 dice has 216 entries. Sample space of throwing 4 dice has 1296 entries, and so on. So we talked about 2 dice. 3 dice is 216 entries. 4 dice is 1296 entries. Entries means that sample space. This is a sample space. At some point, we have to stop listing and start thinking. So we need some counting. So they were also doing something. Somebody came up and put this thing. They said, we'll put some counting rules. So at least till about early 1900s or something like that, we didn't have any specific, like there was no formal rules of probability and all. So a Russian mathematician known as Andrei Kolmogorov was the first person to put a formulation to probability. So he's the father of modern probability or something like that, you can think. So usually Russians, usually from East European nations, they have contributed a lot to probability, cybernetics, all you name it, they are genius. So how this genius comes, why we don't come? Yes, Indians also have done a lot of work in probability, especially statistics. So the way the mathematics is taught is entirely different. So one example if I give is like, for example, so we all learn mathematics from thinking about the Euclidean space. And every orientation of our scientific understanding is towards the South Pole. What happens if we think that if we have all our scientific thinking towards the North Pole? So that's a different, the magnetic properties is changes, everything. So that's how the thinking of probability or mathematics is put in the heads of young minds there who think and all. If, for example, Chinese have their orientation of magnets or something like that towards north pole, because they are more convergent towards the north pole. But all our science textbook, all our magnets and all are oriented towards south. So do you agree? I think you have seen the magnet and all. So all the scientific principles behind that has been towards the south pole, not towards the north pole. So what I'm saying is like how things came up, why they are geniuses and all. Especially East European nations have even today as I speak a real genius in mathematics. Cannot be. So an MNN rule. If an experiment is performed in 2 stages with m ways to accomplish the first stage and n ways to accomplish the second stage, then there are mn ways to accomplish the experiment. Things become a little complex from now on. So this rule is easily extended to k stages with number of ways equal to n1, n2, n. So bit in something. So probably you might have seen this kind of a thing, like put like 1, 2, 3, comma, dot, 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 and all. Why we put that thing? It's an assumption which we try to make in probability. Example, toss 2 coins. The total number of simple events is 2 into 2, 4. Example, toss 3 coins. The total number of simple events is 2 into 2 into 2 is equal to 8. Toss 2 dice. The total number of simple events is 6 into 6. That's what we saw in that experiment. Toss 3 dice. Total number of simple events is 6 into 6 into 116. Example, 2 M&Ms are drawn from a dish containing 2 red and 2 blue candies. The total number of simple events is 4 into. That is equal to 12. So this is the way we start counting things. When we have countings, I think we have learned about permutations and all already in our school days. So the link is given here. So the number of ways you can arrange n distinct objects taking them r at a time is PNR. That's what we call it. So it is n factorial by n minus r factorial, where n factorial is n into n minus 1 into n minus 2, so on up till 2 into 1, and 0 factorial is always 1. So people never thought about this thing, but they made this contribution like 0 factorial should be. Like the way you don't have 1 divided by 0 cannot be possible. So that's how somebody made a rule to it. But if you think it in a very alternative way, it's quite possible 1 divided by 0. So they gave an articulation, they told a rule something cannot have it, something like that. So 0 factorial is always 1. How many 3-digit log combinations can we make from the numbers 1, 2, 3, 4? Simple thing, I think the digit locks and all. I think as a child I was very interested in this thing. It had made a appearance at that point of time. So I had father had bought me one out of sheer curiosity for him also and for me. I don't know, like that was a in thing. Today, I don't know, like people may use this kind of thing, and then I'm not sure. But log combinations are all probability theory. I don't know, like what's that movie? Remember that. You try to break open a safe and all. So what's the kind of locks put? I can't remember that immediately. It's an English movie, very good movie. So, how
Is
many?
it catch me if you try? Catch me if you. That is a movie, na? That
Yes.
catch
Yes. Right.
me if you can.
Yes. So these are some places where they have used. So it is shown more dramatically in this thing, but actually it's a probabilistic way. That combination. So it's an algorithmic way or something like that. You can think. The order of choice is, so how many 3-digit log combinations can we make from numbers 1 to? So there are 24 ways. So somebody is trying to break a lock. So 24 different kind of a way he has to think and get the lock open. In robbery. So Professor Amarnath is something bad. Sorry for that. But yes, they're trying to break open a lock. So you have to use 24 different criminal way of breaking open a lock. So that's how that is probable. Of course, it's permutation. I'm telling like why that linkage is there. So a lock consists of 5 parts, can be assembled in any order. A quality control engineer wants to test each order for efficiency of assembly. How many orders are there? So slowly, an example comes here. So breaking away from dice, lock, card game, etc., etc. It is about quality control now. How exactly we trying to do it? Order of choice is 120. How many orders? So these are some kind of things you have to think like. A lock consists of 5 parts, can be assembled in any order. A quality control engineer wants to test each order for efficiency of assembly. How many orders are there? There are 120 ways. So this is an example from QC or the mechanical, automotive, something like that. So if we talk about permutation, then I have to talk about combinations. Number of distinct combinations of n distinct objects that can be formed taking R at a time. So that is known as CNR. So n factorial divided by R factorial into n minus R factorial. That's how we try to learn it. 3 members of a 5-person committee must be chosen to form a subcommittee. How many different subcommittees could be formed? So 10 subcommittees, different subcommittees can be formed. So permutation is like how many ways you can do it. Here is like a choice has to be made. Distinct objects. Number of distinct combinations of n distinct objects that can be formed, taking them R at a time. So the distinct combination. So there are 10 things, 10 ways can form the subcommittee. So there is a difference between permutation and combination. Both are not same. Formula also differs, and the way which you have to understand also differs. A box contains 6 M&M candies. Four red, 2 green. A child selects 2 M&Ms at random. What is the probability that exactly one is red? So 15 ways to choose 2 M&Ms. That's all. So if somebody like you are in different kind of business situations, the business processes, business projects, whatever it is. Somebody says that, like, how do you think about this thing and all? How you have to run a testing process, whatever it is. These are some things we need to think about. So one green M&N, there are two ways. One red M&1, there are four ways. So 4 into 2 is 8 ways to choose one red and one green M&M. Exactly one red, 8 by 50. See how things like this speak and all. You are in finance, you are in sales or something like that. How to bring that probability, permutation, combination, everything. See, when you talk like these are some statistics you talk about. So coming to a card game. So how many of you play solitaire? You have time. Nobody plays on the laptop, something like that. So when I'm stressed out, I play a lot. I think some of you do play solitaire, right?
I did actually. It's a combination track and it was very interesting. Nowadays not doing, but when I was college, my friend computer is playing.
So even today I do it. Of course, like I may not do it on my company laptop. My other laptop will be there. I usually do sometimes. I'm totally stressed out or something. I play 2 or 3 games. Okay, so that's about the card game. As I told you, probability means gambling only completely. So this is an example. Like if somebody are playing like this, it's a gambling at the end of the day. For fun also people play, but for money is the main thing where people play this pickup. There are many things, solitaire, etc. I don't know, I'm not aware of much things and all. But yes, you have got n number of different games, deck of cards. So a deck of cards contains 52 cards, as you always know. 13 kinds in each 4 suites. So the 4 suites are spades, hearts, diamonds, and clubs. The 13 kinds are, there will be one ace, 2, 3, 4, 5, 6, 7, 8, 9, 10. You have a jack, you have a queen, you have a king. That's the combination of 13. In many poker games, each player is dealt 5 cards from a well shuffled deck. I think if somebody has seen the Quantum of Solace or Honor Majesty Secret Service James Bond movie, anybody? I think that was about card game only, right? The plot was about a card game.
Casino Royale, it was.
Casino Royale, yes. Thank you for correcting me. Yes. That was about this thing. So that's a poker. I think it was a 5 card poker only, if I'm right. I love George James Bond, and I have seen that movie, I think, I don't know, n number of times. Because I'm a probability theorist, statistician, love maths. I don't know, very dramatically they show, but that's a game of chance only, whatever was played with. So this is 52. Of course, you have jokers and all. Jokers are not part of only part of that game, Rami or something like that. Otherwise, Joker, there will be 2 jokers. So it will have 54 cards in a pack of the bundle, which will buy it and play. 52 cards are very much important. So in many poker games, each player is dealt 5 cards from a well shuffled deck. So what are the chances? Like 52 C5. So there are, I don't know, how do you spell it? 2 crores, 59 lakh, 8,960 possible hands. That's the combination of that shuffle. See how things like. So how one has to calculate in some mind. So what's the chance? Like I think that play when it was a start, there was 3 plus 3, 6. I think 8 people were there. You had some from Africa, a Chinese guy. You had somebody from South America. There was somebody from America itself. Of course, Bond is British. Somebody from Japan or something like that. So these are just to show a diversity they show and all. In 8 different things and all. I don't know how Bond is not intelligent or something, but maybe he should have played the game. Then only luck is different. The probabilistic calculation is mind and all. What is the chance you'll get that? It's a shuffle. So we do this shuffling actually. Even today, like today morning, I was talking to an associate there. He was not getting the right results. I told him to shuffle. Using the R programming language, you had a set of data and all. So what data will give me correct result? So we shuffle the set of numbers, the records actually. So it is used as part of our data analytics strategy. So 4 of a kind. 4 of the 5 cards are the same kind. What is the probability of getting 4 of a kind in a 5 card?
Professor, the first before question na 52 previous slide. Previous slide. Okay. Yeah. The 52, 51, 50, 49, 48. Then it will go 47 till 1.
Yes.
1. Then it's because the 5, 4, 3, 2, 1. Then it will calculate. Yeah.
Yes.
Okay. Okay. Got it. So we have that probability, maybe the intermediate or engineering not there, somewhere it was there. So probability and statistics.
Yeah, in engineering also they teach. For computer science, for electronics, for mechanical. I think most of the thing, at least the semester 1 usually are taught.
No, first, second, third, fourth. First year, second year. 4 semester we have mathematics.
Okay.
For me, it's very difficult to do mathematics.
So you learn mathematics, you can win anything in life, right?
Electronics, telecommunication. My branch was electronics and telecommunication. So that 4 year we are studying. Finally, it is complete.
Okay. So I think you might have studied AND gate, NAND gate, and all, right?
Yeah, I forgot actually what I learned in, but I remember the linear programming, linear equation also we learned from the engineering.
Yes.
It was there, linear equation.
Yes. So AND gate, NAND gate, if somebody is
It is there actually. The fourth, somehow clear my mathematics, I was happy.
So whatever electronics which we or whatever the laptop which we have is basically that AND gate, NAND gate. So power in, power out. So that's the problem.
Okay, and yeah, truth table and is okay. This integrate. Okay, I got it. Okay.
Yes. Truth table, whatever we are talking about, is basically a probabilistic table. Perfectly right. So whatever the chips we use, something all are all probability ones.
It's there 8086 the chips of the computer 8085 microprocessor. Okay.
So So there are 13 possible choices for the kind of which to have 4. So 52 minus 4, 48 for the fifth card. Once the kind has been specified, the 4 are completely determined. You need all 4 cards of that kind. Thus, there are 624 ways to get 4 of a kind. So probably in a movie or something like that, they make in a 5-card game, 3 should come the same kind of a thing, 2 should differ, or 4 should come correctly. So it might be K, 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 or something like that, or A2, 3, 4, or 4 A's should come there. So bond should think 624 ways. But I don't know, in 8 combination sets and all, who has what type of cards? That will not be one deck of cards. I think 2 or 3 deck of cards will be fixed. So see the combination. So that's our thinking like. So probability will be 624 by that number which we saw, that is about 0.3024, something like that. So that's a probabilistic number which we do it. So one pair, 2 of the cards are of one kind, the other 3 are of different kinds. What is the probability of getting one pair in a 5-card hand? So 6 possible choices. There are 12 kinds remaining from which to select the other 3 cards in hand. You must insist that the kinds be different from each other and from the kind of which we have a pair. Or we could end up with a second pair, 3 or 4 of kind, or a full house. That's what full house, so we see that. So here, the last thing, I don't know, he goes outside, he has a heart attack, all fancy things they show. He comes back, he drinks salt water, and he might be poisoned or something like that. Something and all happens in this thing. All the dramatic dramatization and all they do. He achieves a full house, he wins it actually. So that's a full house, we call it in a poker game. So what are the ways to pick? That's one problem. When we come to event, the beauty of using events rather than simple events is that we combine events to make other events using logical operations and or and not. Survi was speaking about to her question, I was talking about AND gate, NAND gate, and all. So these are all some kind of logical operations. Here also we see that and or not. So union of 2 events, we write it as A union B. So mix everything together. That's known as the A union B. We saw something shades of it in our example on that sample set. A intersection B, or Venn diagram, if you remember, that's the intersection B. Same thing here. So if 2 events A and B are mutually exclusive, then probability of A intersection B is 0. I mean to say nothing will fall under that intersection logically. A complement of A event consists of all outcomes of an experiment that do not result in event A. So we write that as A complement. An example, select a student from the classroom, record his or her color, hair color and gender. A event, student has brown hair, B student is female, C student is male. What is the relationship between events B and C? So have an A complement, B intersection C, B union C.
Say B union C, because the male and female in no, sorry, this is a intersection between, because hair color and the gender. Yeah, sorry.
Student is both male and female, it's a null set. Student is either male and female, all students put together, that's the whole sample. So calculating probabilities for union and complement. Special rules that will allow. So Kolmogorov was the person who came up with this thing. So it was in early, because probability has been there from 17th century itself, but he didn't have formal rule and all. He put this kind of rules and all. And in the programming kind of situation also, these rules have been implemented like a business logic.
Every programming language, the database also it is there. Union, the SQL, Oracle is there. Union, intersection, union all. This logic implemented.
Same logic has been in, because numerical calculation across anything has been the same, and that is because of that Russian mathematician only. So the additive union, that's a formula. So an example, suppose that there were 120 students in the classroom and they could be classified as, so male brown who had hair 20, not brown 40, female 30 brown, 30 not brown. So probability of A is 50 by 120. Female 60 by 120. So additive rule, A union B 50 by 120 plus 60 by 120 minus 30 by 120. So that is 2 by 3 is a way probability. A union B is 2 by 3. So sample of 2 dice. Red die show 1, green die which shows 1. So it is 11 by 36. Some special case, when two events A and B are mutually exclusive, A intersection B is 0, probably A union B is probably A plus male with brown hair, female with brown hair, mutually exclusive. So that is 50 by 120. Dice example 7 by 36. So calculating probabilities for A complement. So what is not in A is A complement. We know that means that's a rule is there. Theoretical textbooks talk about this. Because for a sake of continuity, it's been given here. That's all. The probability of A complement is 1 minus probability of A. So all probability in that square box will be 1. But P of A will have some probability. A complement is 1 minus of that thing. So that's a true. That's all. Select a student at random from a classroom. So PB is something which I need to find out. It's an A complement kind of thing. So that is 60 by 120. We found A intersection B directly from the table. Sometimes this is impractical or impossible. Rule for calculating A intersection B depends on the idea of independent and dependent. So A and B are said to be independent if the occurrence or non-occurrence of one event of events does not change the probability of occurrence of the other event. We come to conditional probabilities. Probability that A occurs given the event B has occurred is called conditional probability of A, given B is defined as 0. This is how we write this conditional probability. That sign is known as given. I think we can find this thing on our laptops also. See, for programmers, they know it as a piping symbol, if I am right. So toss a fair coin twice. Head of second, A is head of second toss, B head on first toss. A given B is 1/2. Probability of A not B is 1/2. PA does not change whether B happens or not. A and B are independent. A bowl contains 5 M&M's candies, 2 red and 3 blue. Randomly select 2 candies. A second candy is red, first candy is blue. Probability of A given B is half. A not B is 1/4. PA does change depending on whether B happens or not. So A and B are independent. The dice example. So in this case, probability of A given B is equal to probability of A. So with 2 dice, probability of A given B is 0. So in this case, the logic changes. A and B are dependent. In fact, when B happens, A can't. PA does change when B happens. This is about defining independence. So multiplicative rules. They have an addition, it should have a multiplication. In a certain population, 10% of the people can be classified as being high risk for heart attack. 3 people are randomly selected from this population. What is the probability that exactly one of the 3 are high risk? So exactly one high risk is 0.243 is probability. From the randomly selected 3 people, what is the probability that exactly one of the 3 are very high risk is what which I need to find out. This is an answer. Suppose we have additional information in the previous example. So like Surabhi's example, like second half of the match, rain comes. That's an additional information he wants to model. So we know that only 49% of the population are female. Also, of female patients, 8% are high risk. Single person is selected at random. What is the probability that it is a high risk female? So we use a multiplicative rule. So we get an answer that what is the probability? It is a high risk female only. So it is 0.069. Law of total probability. So base rule. So we started with sample events. S1, S2, SK be mutually exclusive and exhaustive events with prior probabilities. If an event A occurs, the posterior probability of Sy given that A is occurred is this formula. So for every event, there is a probability attached to it. So posterior is like after we model, like what is the probability which we get is what we trying to answer to this base rule. The base rule comes when there is a prior information. That's it. So previous example, we know 49% of the population female. Of the female patients, 8% are high risk, but 12% male patients are high risk. A single person is selected random, found to be high risk. What is the probability that it is a male? So this is prior probability, we know that. posterior probability that he is a male is 0.6. So that's what will talks about. One more example. One more example of job satisfaction. So people do is it in a live settings and all, how to calculate. Numerical calculation. So it may go overboard. I'm just skipping and going and all. You can calculate it, you will get this thing, it's not a problem. So I'll stop here for today. So let me continue this thing my next class, and we have to speak about this thing also. We have to do this probability calculations also. So when we meet the next thing, we'll talk about this thing like we had factorial, how to calculate permutation combination, the expected value. Hello, somebody spoke something?
It's a background noise.
Okay, okay. So we'll have to learn about this thing. Then I talk a little bit of one of the distributions that we'll touch base on the next class. And so,
Sir, when
Not
is
that-
next class, sir?
so it will be
Monday.
on Monday. I think and you people have classes. That's what you told. Like morning and afternoon also you have class, right? That's what you told.
Yes, Monday is
Yes,
there.
tomorrow your class only, I guess, sir.
Yes, yes, my class only. So because I had kept this because it was a 2-hour thing which I wanted to cover this thing, but I don't have a window, so I had to cover in this 1.5 hour class. So next week we'll touch base on Monday between 7 and 8:30. So next week, like I may have 2-hour classes also evenings, and it may not be day after. It might be like continuous. You may have Monday, Tuesday also, because I have about 2.5 window which is being given by the university to cover this thing. I have to abide by that thing. So we may have to. I will not rush. Only thing is like I may have to take some more time for to cover some things. Will that be okay?
Yes, sir.
Yeah.
Instead of 1.5 hours, we'll do it 2 hours, sir. That
Yes.
way we can.
So at some times I'll not force you also because you'll also be tired from work. So that all will be there. So might be we might have Monday, Tuesday, Wednesday also like that, or say Monday 1.5 hours, Tuesday it will be 2 hours, something like that. I have to balance.
Sir,
So
you will be
that's-
taking any subject on the third semester?
Sorry.
For our third trimester, will you be taking any subject?
No, I don't take any trimester apart from the T4.
Okay, sir.
So I concentrate mainly on this things. So that will be this thing. So again, then let's meet on Monday. So at 7 p.m. But any change, anything like that, please be seeing your this thing WhatsApp group. I'll let you know correctly like when we meet. But the next class will be on Monday. Is that okay?
Yes.
That will be fine, sir. Sir, how about the class video, sir? It is uploaded now?
I think so, man. I don't know. Like I don't know. I've been asking. Like I'm not sure. Like what's happening.
Sir, please help us on this, sir. Just if you can speak to
Yeah, I
Pawan.
had contacted them because I don't know. Like they told they will do it and all, but I don't know. I'm not sure. Like why this is not happening. They should have been done.
It's a little annoying, sir. Let me be honest with you.
Yeah, that's there. Even I know because there are some challenges.
So
People
what
do-
happens is as we more progress now, we feel like going back to your lectures.
Yeah, I
Will you-
understand. Definitely, I know that. I know the travails of a student, not the problem. But yes, I don't know like why this thing. The first time it's happening. For what reason, I'm not sure. Like
Yeah,
The probability is there. The probability is there. The people can share the recording with other people. That's why they're holding this maybe.
No, why should we share? No,
Why on earth?
Probability is there, nah? That's why.
Well,
I
in
just
that case,
probability we use and you are using probability. This
Surabhi, in that
thing